the x64 backend in a long time. Okay, so let me even refresh myself about how array bounds checking works. So here we say emit code for array bounds check. This is in our internal representation, right? So in the bytecode, and this happens on all platforms. And we have an instruction for array bounds check, right? Okay, so let's look at the C. The C backend is probably the easiest thing to understand in terms of what it does. So, whoops, there's no source. Array bounds. So when we get this bounds check instruction, we do a check to see if something is in range. And if it is not, then we call array bounds check fail with, what are the 4 arguments? File name, line number, and the indices. Okay, you know what? Let's not do this one yet. We can do it later. It's just, it's not a good warm-up one because it's going to be a lot of work, actually. Because, like, calling a procedure and getting a string, and it's going to be a little involved, like doing this stuff. It's going to be a little involved. However, we can start with one of the smaller ones, and it'll give you guys more of a flavor of the x64, and then go on to this one. Wait, what? Did something else win? It says array bounds checking, right? And then bug fix the 16-bit signed to unsigned casting. That's also an x64 bug. That only happens in x64 mode. What do you guys... No, it didn't. Using it top level, I'm looking at it right now. Using it top level has 9 votes. Array bounds checking has 11 votes, unless you're getting different reports than me. Unless you're getting different reports than me. Using is, yeah, it's at 2nd place on mine. All right, fine. So we're going to do array bounds check, but we're going to get there via another bug because it'll be good to warm up, and I'll probably solve it faster anyway if I warm up. So let's look at this scroll wheel thing, and I will reproduce that in a simpler way. And that'll get us into x64. So we're going to look at console, right? So we do a divide. Oh, so it's S32. It's probably just S32 to int. Or it's the divide. All right, so let's just go to main. I'm just going to put some stuff at the front. I'm going to say A is an S32 that equals minus 720. B is an S32 that equals 120. C is A divided by B. D int equals C. Print D is blah. I don't remember what color switches these are, honestly. Okay, D is a very large integer. That's wrong. So that's good. Okay, C is already screwed up. So it's got it. So E is A times B. So the multiplies, it's really just the divide. So there must be something in x64 about, no, I was wrong when I said x16 a long time ago. I don't think there's any 16 bits. It's only 32 bits. So what's happening here is it's just, for some reason the divide is, there's probably a signed divide versus an unsigned divide, right? In fact, I can almost guarantee that's what there is. So let's look in x64 now. Integer divide, bin op, math bin op. Here we go. So this is where all our binary operations happen. And so for each one of these, so here's logical and, we do a bunch of instructions, right? Logical or, we do a bunch of instructions. And these are just all quick procedures that output x64 instructions. Okay, so divide for integer, we just call idiv64, and we say put 0 into RDX, and we do a 64-bit prefix, opcode F7, and then this mod RM. Oh God, it's been a little bit since I've done this, and I allowed myself to forget how heinous x64 is. So x64 idiv signed divide. Okay. I actually want a signed divide though. So why is it not right? Maybe my sign extension. So the thing is you divide like RDX colon RAX, right? So I'm going to have to make unsigned divide work as well, apparently. Okay. Right, so the problem is I'm putting 0 into RDX, and we're making a big number here of RDX, RAX. So it's supposed to be a 128-bit number, and if there's 0 in the top bits, it means it's positive. So we're making a big positive number before we divide. So that's a problem. And then I want to look up unsigned divide before I do this, because we want to maybe do that as soon as I fix this. Oh, come on. x64 unsigned divide. There was a nice site. Oh, this one, unsigned divide. Okay. This is the site I'm used to looking at. What? Look at all these instructions. idiv. Okay, so idiv is signed divide, div is unsigned divide. Okay, so since the only divide we're trying to do right now is a signed divide, we'll make that work, and then we'll make unsigned divide work and test unsigned. Okay, so we're doing this version is the only version that we're outputting. So we're doing 64-bit extension, F7, opcode extension. That /7 is sort of this 7 down here. Okay, so I need to sign extend into RDX. So I'm going to say bool signed divide equals false. Incomplete, this will be a parameter. If signed divide, we do something else. So we either sign extend into RDX or put 0 there. So x64 sign extend. That's not what I want. x64, does anyone happen to know in x64 how I would fill a register with ones? I could move this opcode into RDX. Let's do that. Unless someone has fill RDX with ones, this is probably not the best way. I could say move 64 RDX op1 and then shift. Oh God, I need to shift arithmetic right RDX by 64, 63. Check the instruction CD CQO. All right. Whoops. CQO. Convert word to double word to quad. What? That's not. Oh, okay. Oh, right. But this does not take an arbitrary operand, which sucks. But it's fine because I think I can hard code it to always take RAX. Convert. Okay, we'll try it. We'll do it. We don't need to. We'll say C CQO. So add the extension W, and we'll add a 99. That's it. So oh geez. Oh wait, so idiv already is just on A, right? Yeah. So these two instructions are basically made to go with each other. Okay, so that maybe fixes it. I don't know if that's right. It takes so long to compile the compiler now because C++ is annoying. Okay, that still didn't work. Oh, because I set this to false instead of true. Duh. You got to ask for the sign divide if you want the sign divide. Thanks for the CQO. Why not just immediate move RDX with Fs? Because I don't know. Because it's a signed number doesn't mean you know it's negative, right? It could be a positive. So you only want to put Fs there if the high bit is set. All right. Hey, look. I bet if I go here now, I can scroll up and I can scroll down. Oh my God. Oh my God, Becky. Look at that scroll. That's bug number 1 down. But in doing bug number 1, we saw bug number 2. I'm going to pass number flags. And in number flags, if number flags and number flag signed, true, false. So number flags, we went into those into a stream a long time ago, but they basically just tell you aspects of a number, like how big it is and stuff. What about mod? That's a good point. We need to test mod as well. But we're going to be forced to do that actually because, yeah. So here, so basically we have to go to all our idiv64s. Okay. So that's all good. Now the thing is, we're not really doing the right thing. So this is idiv. Come on, Emacs, what? That's idiv. And this is div, which is probably 1 bit off from idiv, right? So div is f7/6. Whatever, we'll just make it separate. Okay, so in theory that fixes everything. Oops. You know, sometimes I get bummed out that my error messages aren't that good, and then I see this kind of garbage. This is all because of one, yeah. C++, nobody cares, it's all terrible. 856, whoops. No, it's not even giving me the right line number. Oh, wrong file. 856. So I just need to do this because I declared a variable in there. I left both of them at 6. Oh, thank you. Thank you. That paste errors will kill you, man. Paste errors will kill you. paste errors will kill you. How do I have 94 quotes already? We were only at like 40 last week. This is ridiculous. All right. So, okay, that's all working. Let's try mod. Let's make it 727. A mod b print m is, all right. Yeah, I guess that's right. I mean, of course, it's up in the air what the actual result of the mod operator should be. My taste, I think, is that maybe in this language, mod is always going to be positive, maybe. You know what I'm saying? I'm not sure I dig negative mods. But yeah. So now we've got to test the unsigned divide with a big number. So let's say OX 100 or F000, right? B is going to be 256, right? Hey, look. B is going to be 256. C is A divided by B. A and format float A comma int or A comma 16. Format int A base equals 16. Format int A base equals 16. Is there any reason, can anyone think of a good reason for mod to be negative? If not, I'm actually going to put this on my list. Positive mod. Second one should be format int B. Oh, thank you. I'm making so many mistakes today. All right. 1, 2, 3, 4, 5, 6, 7. So that appears to have correctly done the unsigned divide, right? Because if it, well, okay, I guess. Yeah, I guess that's right. I mean, we could also do this. Well, that's not going to work. Okay, here's 8 Fs, right? And B is going to be OX 800000, right? So that, no. I'm trying to have the denominator be negative and see what happens. I guess I could divide by -1, right? I could have divided by OX FFFF. So that's -1. And this is, well, I could just, yeah. Let's have this be 42, right? I mean, that should be -42, right? Yeah. Okay, so signed works. Wait. I'm confused now. I'm confused now. So this didn't work somehow. Wait. So this is a signed number divided by 256. Oh, wait. Okay. Right, so that's correct. I must have printed the wrong thing before, yeah. So that's right. We wanted to make sure that we keep our negative thing. Yeah, that's about right. But if we make these U32s, okay, so now, right, now we get the correct thing. All right, so I'm convinced this works. With negative mod, you can just add the denominator. If the result is negative, you get positive mod, so you can get both. Only positive mod would give you less info. No, because you can check the signs of both of your things. Basically, nobody, like everybody always works around negative mod and it sucks. Like, I don't think there's any legit reason to have it. All right, so that is a bug fix. In fact, it's 2 bug fixes at least. Fix issues around signed versus unsigned divide mod. Let me just make sure that we can still scroll. Yes, we can. It's the Barack Obama scroll. Yes, we can. All right. So that's such a great first sentence for a science fiction story. Just saying. Why would you use mod with signed integers? It just happens all the time. Come on, man. If this were the Donald Trump scroll, first of all, I'd have to take out all that UTF-8 functionality we did last night so that we can't print Korean or actually we would be able to print Russian, so that part would stay. But like Korean and Arabic and stuff definitely would not stay. All right, so let's go to the thing that won the vote. Well, wait, let me cross off the scroll wheel bug. That makes me feel good. Now, the thing that won the vote was the array bounds checks. So I'm going to start by just making foo sailor is an array of 3 ints, and hello is sailor sub 5. Print hello is blah, comma hello. So that is not going to generate an array bounds check failure. On x64, you see we just run, it says hello is 0. We grab that past the end of the array, right? Whereas if we go here and we turn on LLVM, It says array bounds check failed in main 266, which is the right line. So we have to make that happen in x64, which is going to be a little bit of a pain in the butt. We'll do it piece by piece. Maybe I'll pass an empty string for the file name first and get it working, and then we'll do the file name. All right. So let's go back to x64 and array bounds check. Look, it says incomplete. And here's the C version commented out. Okay. So we need to, yeah, this is going to be enjoyable. It's going to be a big thingamabop. Okay. So we're going to do so here we do our less thans. Oh, right. Okay, so so we're reading stuff. It's going to be a little bit confusing because we say register here. This kind of thing is like byte code registers and not actual registers. And this is going to be annoying because I also have to handle signed versus unsigned here. Okay. So we got to get the number flags. We're going to do something if we're signed, otherwise we're going to do something else. Let's do the now let's do the signed version first because that's harder. And it's also what we're using because in main, by default, integers are signed. So this will be a signed array access. So if we're signed, then we need to do all this stuff. Okay, and I'm just going to paste it. So we get in A, which is the index. A is the into RAX. We're putting the subscript of the array, like that'll be the 5 that we just put or whatever, into okay, so now we'll say we'll zero out C first, and we'll compare against 0. 0. Output here is just the buffer that's holding all the assembly code that we generate. So we're going to 0 RCX, and we're going to say, because you don't have to check against 0 if you're unsigned, because an unsigned number is greater than 0. So you get cheaper array bounds checks on unsigned. Okay, so if it's signed, then we want to jump if less and then we're going to want to fill this in. We want to do the compare. We want to compare RAX versus RCX. And then this JCC, this is an 8-bit relative branch, which means I could branch forward by 127 bytes or backward by less, right? And so I'm going to patch that later, and the way I'm going to do it is I take these post branch A is like, okay, this is where we are. I actually don't think we need but we need byte storage branch A, which is this -1. So later when we know when we're going to jump to, we're going to stomp on this 0 byte and put something non-zero there. As follows. So what we're going to do is we're going to jump to the fail case, right, if this happens. So if that didn't happen, then we're not going to jump. And now we need to test if it's greater than the array bound, which is in index B. So now I got to load my index B into RCX. So RAX still has the subscript, and now RCX has the length of the array. And I want to say greater than equal, and it's signed. Jump if greater or equal. And this is another thing that I'm taking note of. Okay, and now if I didn't do either of those, then we're successful, and we want to just fall through and do our regular code, but we're about to insert code that screws things up, so we want to jump around the regular code, right? So here we say, jump relative 8 and this is branch C. So now down here is like, okay, this is where we get if we detect an array bound failure. And what we would do here is we'd call a procedure. That is not going to work yet, or it's more work, and we'd rather just test this before we try to do that. So I think, isn't int3 like just oxcc or whatever? Do I have an int3? Yeah. Okay. So I'm going to say int3 crash. So if it crashes on that array access, we'll actually know that we were successful. And then we'll go fill out this crash with a call to something better. But now, if we got here, we want to proceed onward with our regular code. So okay, so from here we say, int point equals output.length. This is just where we are now. And now we have to compute relative distances for all these jumps so we can go in and stuff them. And of course I could hard code these by knowing how many bytes these are, but then that's a nightmare if you ever like change this code. So what we're doing here makes it robust, right? So I'm going to say auto branch A distance is point. Oh, we do need this. Okay, so here's the funny thing. This is the position where the byte goes, but the branch is relative to the address after the whole instruction. So it's relative to this. So you actually want both of these. I mean, they're only off by one, but it's easier for me to think about if I just do this. Post branch A, right? And then I modify 1B byte storage branch A distance. And I just do this for A, B, and C. Does that make sense to everybody? Does that make sense to everybody? Isn't byte storage branch B supposed to point to branch B minus 1? Yes. More paste errors. Thank you. Dude, you know what would be the greatest thing is just like a little AI dealie that like detects paste errors like that, because that would be good. All right. Maybe this is right. No, it didn't work. That's a bummer. Oh, I didn't recompile the compiler. Thus, we should not expect anything different. Size undeclared identifier. All right. Still failed. Wait, what? Oh, because that's all C undeclared identifier. Oh, it's output. All right. See what happens. Didn't work. Oh, because, well, I don't know why it didn't work. And this kind of thing is hard to debug, yo. This is hard to debug. Oh, you know what? I moved into RCX and I didn't compare again. I hope someone caught that in the chat. I hope someone caught that in the chat. And that would explain our failure because we're only violating the high bound, not the low bound. Still didn't work. Still didn't work. Don't you need to have a handler set up for int to work? Maybe. That's a... Why don't I just see... Let me just stick one of these out here. Right? Let's see if that works. Okay, that worked. So you do not have to have a handler set up. Okay, well, let's see. Let me put it in here. Let me make sure our number flags are coming out correct. Okay, so if we get to assigned compare, okay, so we're getting to the signed compare. Let me make sure that we're doing that. God, this tastes so slow. Okay, yeah, so we are running this. So for some reason, okay, this should be B. Well, I don't know if it should be that, but whatever. Jumped if greater or equal. Signedness should not really matter here. Wait. I'm jumping to the wrong place. I hope anyone was thinking about this. All of these branches are going here, so they all skip the int3. Nobody's ever going to int3 with this code. They all, okay. This is supposed to go here. So int crash is output dot length. These two want to go to crash. Right? So if we're less than 0, we go to crash. If we're greater than or equal to the index, we go to crash. Otherwise, we jump down to point. All right. Yay. Okay. Now, of course, for all I know, we might have a bounds check. Actually, we probably don't have a bounds check error elsewhere in the program. So now if I change this to 2, we should not crash. Hey. But if I change it to 99, we should. Hey. And if I change it to minus 99, right on. So that's good. 0 should be fine. 2 should be fine. 3 should crash. Okay, so that is good. That is working. This makes me happy. Now we got to call a procedure. And what I think I would like to do is successfully call a 0 argument procedure first. And then we can add arguments. So do I have a symbol for abort or something? I don't. So now, okay, so this file I'm looking at on the left is our object file thing. This one on the left is our object file, and this is what, you know, organizes all the name lookup and stuff. And so what I don't remember yet is how do we, okay, there's find or create symbol, find or create. Okay, and okay, when we init, we find or create various symbols, and some of these are internal symbols and some are external symbols. Here we go, panic due to runtime call of compile time procedures. Do I ever call that? No. So let me look in our runtime support. So I have an abort procedure. I have a panic. So panic just prints abort. I don't really have anything that prints anything. Panic is just going to say printf, you called panic. That's temporary. All right, cd. Let me make a new console up here. Yeah. Okay. So I can test that by going into main and saying abort or panic, right? And you called panic. Good. So now I'm going to try to call that zero argument procedure. Oh, but it's foreign. But that's fine, because anything we call is going to be foreign because it's in this library, I guess. Okay, whatever. If we can do it one way, we can do it the other way. Okay. We'll just say panic. 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 Panic on the streets of London. Panic on the streets of Birmingham. All right, so we need to procedure call. So calling a procedure is hairy. And I guess I want to factor things somehow so we can use that. Okay, first let's go to one thing at a time. So I want to find really? All right. Do I store any symbols here? Nope. All right, so when we start out the obj writer, we are going to make a symbol for panic. So when we init, we're going to say there's just a panic. Put this there, put this there, and panic symbol. It's just going to be that. And then in x64 converter, we're going to say auto symbol equals panic symbol. No, interp obj writer. Or do we have a pointer to the obj writer? No. So anyway, this is going to be the symbol for the procedure that we have to call. Why is there a panic due to runtime calling compile time proc? Couldn't that be statically detected? No, because it's a Turing complete programming language. Like you might have a procedure that you call in some modes at compile time and in some modes at runtime. And you don't want to make that procedure illegal. Okay, so this is the symbol of the procedure that we want to call. And I don't remember very much about calling a procedure, so good luck on me actually making this happen today. Oh, I have an emit code for call to symbol. Holy crap. Does that actually work? No, because it's not. Holy, okay. It is not doing things it needs to do according to the calling convention. So, according to the C calling convention, yeah. So these are trying to do right. Okay, so let me uniform this. I don't need the I'm going to do this the same way. Init code for call to symbol, output symbol. Wait, no, this goes up here. This goes up here. So I'm going to fix all this. So obj writer, we don't put the whole symbol, we just say int symbol index panic equal -1. Symbol index panic. Okay, autos, no. Okay, so there's all that. There's all that. Now I'm going to have to actually make this work. And we'll call this foreign symbol. Well, let's do this. Okay. I'm just going to copy and paste here. Okay, so we are foreign, so we're going to say there's no stack arguments. Actually, I might as well do this. So you know what? I'm just going to make it as pasteable as possible. Because we're going to factor it together hopefully later. Going to Factor all this together once it works. Okay, so now we're actually generating assembly. So that was all just figuring stuff out, and then this bumps the stack pointer. We're not doing a context argument. No, let's not even do that. So anyway, so here we bump the stack pointer. So we're calling a zero argument procedure. That's fine. And then we need an extra 32 bytes, and we're just doing that by an extra sub, so this is inefficient. And what this stack space is for is because you're supposed to reserve stack space for a C procedure to write its registers, those registers that it has to save if it uses them. But you're supposed to make the stack space for them. It's confusing, but it's that way to make things fast. Okay. Okay, so that's the call. And then this symbol patch is a thing so that the linker knows that this is a pointer that needs to be updated as things are loaded. San Francisco is now offering free college. What? I don't know what that's all about. Okay. I feel like I'm going to be able to copy basically all of this into a procedure, but I want to do the simpler version. Maybe this is a mistake. Maybe the better approach is to factor this all first. This is handling return values. And what about our exercise? Wait, what? Dude, do I not ever restore the stack after? What? Dude. Okay. It looks like I'm doing a sub and no add, which means anytime you call a C procedure, you're whack afterward, which would be important to fix. I've written that down as a thing to check. That should be easy to test for, I think. Possibly. Because after you returned, all your variables would be at like the wrong address. I don't know. Anyway, let's get this done. Let's get her done. Or does the callee... No. Dude, I don't know. I don't know. And wasn't there a thing about adding 8 somewhere? Dude. Whatever. This is not going to be right. Info undeclared identifier. So if there's a lot of return values, oh, that's for our other, yeah. I feel like the right move was not to paste it. I feel like the right move was rather to factor all the other stuff out, make sure that still works, and then call it. So if this doesn't work and if I can't debug it quickly, I will do that version of things. All right, well, it compiled. That's something. Who knows what's going to happen? Panic! Oh, wait. Do I still have my manual call? Yes. That's not very exciting. We still want it to panic now. Yes! Dude! Print, pre-check, post-check. So we should print pre-check and then panic. No. What? Why didn't we print anything? Wait, what? What is going on? This is upsetting me now. This is upsetting me. The hell? We just crashed now. Maybe emit code for call to symbol was actually being used for something. And I screwed it up. It looks like it's only being used for panics. Am I sure I'm calling the right compiler? Really, at this point, no. I'm not sure about anything. I think so, though, yeah. x64. I'm just checking right here. So I took out my int3. Yeah. I don't know, man. Oh, you know what it is? You know what it is? So I hastily copied this stuff over, and see how I do this like current stack bytes without bytecode registers? I'm not resubtracting that. And the problem is that code generation uses that. So oh wait, there's the add 64. What what was I talking about? What was I talking about? I am stupid. Okay, that's good. That's not a bug to look up later. I don't know why I didn't see that. Okay, so then so we basically have to subtract this back because this is how, when you generate other instructions, how it knows what the offsets are and stuff. So, gotta do this. Look at all those size errors. It's so weird that it actually worked long enough to panic. But I guess, right, if I panic, as long as I don't ever, right. Sub 64, extra size, argument passing size. You know what, I'm going to factor the other thing anyway, because that's really what I should do. So here we're just not going to do anything. I'm commenting this all out. It was fun. It sort of worked a little bit. It doesn't totally work. And okay. So here's what we're going to do. This is going to be hard to factor, kinda. What's this again? Converter help? Yeah. Argument info. Yeah, that's not going to help that much. Is not the right abstraction for what we are doing. It's okay. We're going to make it work. We're going to make it work. We're going to factor it. We're going to factor it. Okay, this is going to be painful. It's going to be painful, but we're going to do it. Can't I debug the executable in Visual Studio Assembly? Yes, I could. I just don't think it's worth the time because the problem is, you know, we're going to want to be able to later. I was sort of hard coding that for a small number of arguments and only foreign and whatever. And the truth is, we want the flexibility to be able to call anything and fill in the arguments and stuff. And in order to get that flexibility, like we already have a thing here where we can call anything, so I should be reusing this code instead of pasting it. Sometimes I'm fully of the paste first and factor together later school, and that still actually might be the right approach here, but I want to try and factor this out instead. think, okay, we're going to say so I'm just sort of starting to depend less on certain things. All right, let's just try cutting from here down. Boom. Unit code for procedure call. Info. Where does lambda come from? Anyway, info, def and flags, num arguments. So this procedure info is a thing that will be null when we're calling for unknown external symbols, but we'll pass in flags that tell it about what it's going to call. All right. So we've got to do all this junk because we can't just factor it in locally without doing stupid lambda things. Emit code for procedure call. Oh, we need to pass the for procedure call. What are the def and flags? Those are U32. Okay. Now, this is probably missing a lot of things. All right. Foreign undeclared C callback. Okay, so we are going to copy some of these because we sort of want to know them in both places separately. It's fine. Make code for procedure call. Oh, it's not a member, even though I'm saying it's a member. Because C++ is stupid. Now it's a member. BC, undeclared identifier. Right. So that's passed in here. Right. Proc register. All right, we'll just pass proc register. put it up here. Of course, now I have to add that twice because it's C++ and it values my time oh so much. It values my time and productivity as a programmer. Better put it in the same place both times. Okay, so that's actually was not that bad. So if we can run now, then we're happy and we did a good refactor. Yeah. Ooh, yes we can. All right. So now what I'm going to be doing after a 5-minute break and maybe some questions. Whoops. Is then I'll be adding another mode to that for when you don't have like a known procedure from your source code, which is going to be interesting. Yeah. All right. Break. Break. What just launched? Some window launched. I don't like that. I don't want things happening on my computer. Are there any questions about like what the hell's going on? Do I have the notion of a scene graph for the game? Nobody uses scene graphs in games. Scene graphs are for like bad academic computer graphics classes. Nobody does that. No, there will not be switch case fall through. If you want to make that happen, you can force it, but no, there won't be. Someone's asking me, what about the scene graph in pixie.js? Well, of course, a JavaScript thing does slow and bad graphics. I mean, that's no surprise. I'm talking about people who live or die on whether rendering happens quickly don't tend to use such a thing as a scene graph. Games tried to use scene graphs for a while, like in the late 90s and early 2000s, because that was how graphics people did it. And we quickly discovered it is not a good idea for many reasons. Couldn't you do ABC in the front end via AST manipulation? Yes, you could, but you want it to be in the back end because you want it to be really fast. Because whereas turning it on will severely impact your performance, you still want to minimize that impact. And I think probably the best way to minimize that impact and minimize the amount of time it takes to compile is to have it just be something that the compiler understands very deeply and does quickly. No, we don't have go-to right now. Any chance of a rendering stream? Probably not for a while. Like I said, I'm about to not stream for like a month. Who knows though, I might not work on rendering during that month. Although we do need kind of a better renderer than we have. Why is my Emacs not doing things? I think people get confused on scene graph versus able to parent transforms or link transforms like that. Central to any of your recent game engines? No. Nobody does hierarchical transforms. It's not. That's one of those things that's like, seems like a cool idea when you learn it. And then when you figure out how things work in the real world, you're like, oh. I mean, you can have a thing where it's like, oh, the transform of this thing is relative to this other thing. Like, that's how skeletal animation works, for example. But in practice, that has very little to do with how we represent the data or how we render the data, right? So by the time you have a fast renderer, all that stuff is just like, well, that happens to be the relationship between these two transforms. It doesn't have anything to do with how you handle actual rendering of the scene, if that makes sense. I got sticky keys enabled. I don't have my headphones on and no speakers, so I can't tell. All right, let me get going again. If I'm going to have a hope of doing this tonight before I pass out. So we do the submit code for a procedure call, and if we're doing a call, this procedure has two modes. If called from via bytecode call procedure, info and proc register will be set to valid things. If called by other means, for example, to generate a panic Info will be null and proc register will be -1. In this case, and I'm going to do a callback for this. But callback will be set to a non-null procedure breaker. All right, so we're going to say void callback with no params. That should be fine. It's going to be gross and stupid, but that's how it is. See if that compiles. No. Does not take 5 or obviously, right? For procedure call info proc register null. Okay. Let's do a little checking on that. So if callback assert info is equal to null, assert proc register is equal to -1, else assert info is not equal to null, assert proc register. Wait, proc register. Okay, actually, we won't make claims about proc register because it might be -1 anyway, I think. Why x true : false instead of typecast? Because I think you're not really guaranteed to get the right value if you typecast that. I'm not sure. Maybe that's only in C. I don't know, but I see people do this pattern a lot. Like if you cast this to a bool, maybe you just get the lower 8 bits or something, which might not be set. I don't know. Or maybe you get a non-zero value that's also not equal to true. Okay. So now we search for where info is used. I'm just going to look for a second. So that's argument passing. So this is all going to be under if info, right? Argument passing. Oh, actually, that callback. So first, we're going to call it something besides callback, and it's going to take an argument. So bool. It's going to take a Boolean about whether we're doing the preamble or the postamble. Code gen callback. Okay, so no lambda is null if info no lambda equals info no lambda. Right, so we can I need to think about how that works. No, that's not good anyway. It's not good. Okay. Else. Oh God. It's like I want like 3. I want to pass an integer. C++ is a waste of my time. Code gen. Stupid enum code gen mode. Passing arguments equals 0. Passing returns equal 1. Calling procedure. Let's make that one passing returns equals 2, so they're in order. Okay, so if info, else if callback, codegen callback, codegen callback of, what did I call it? Calling, passing arguments. All right? And then down here, if info, else, if codegen callback calling procedure. This is going to be, I don't know if I'm going to like, this is going to be a little slower than I would prefer. Whatever. All right, so this is totally one of those things where you just want to pass a procedure and have it bake it in. Actually, no, that's probably not true, but yeah. Okay, and then the hell is this? We're getting nested here, else passing returns. I'm getting annoyed with how much dithering I have to do here. Codegen callback. All right, let's make sure that things still run, shall we? We like it when things still run. All right. So now we're actually ready to do something with this. Okay, I will say emit code for procedure call output null -1 codegen underscore panic def and flags u32 def and flags equals type def definition lambda is foreign. Okay, so we're going to do that. Got to go somewhere where I can insert code. Void, static void, code gen panic, code gen mode. Oh God. C++. It's trying to get me to do lambdas, and I'm not going to do it because they're stupid in this language. All right, we're going to pass another argument. I have to do it twice. Every single time I change this thing, I have to do it twice because C++ values my time. Too few arguments for call. And it takes so long to compile. Code gen panic. All right. Switch, mode, case, passing, arguments, break, case, calling, procedure, break, case, passing, returns, break. So annoying that I have to do all this. All right, see if that still works. It appears to. Okay, we didn't crash, that's good. Print f, we didn't crash. Right. Okay, that's good. We're actually using this code with info equal to null. Although I'm confused by, yeah. Okay, there's one thing I didn't do, which is this. Temporary, we are not yet calling this in the info is equal to null case for non-foreign procedures. So we just dereference null here. If we want this, we will need to pass none returns as an argument. All right. So let's do some code gen callback. Passing arguments and getting returns will do nothing. Will do nothing. All we're going to do is this. Gen panic. All we're going to do is this. All that structure, I think, was just so we can do that crap. All right, C undeclared identity. Oh, I gotta. C++. Oh my God. I have to change this everywhere. At this point, I should have type defed it or something. I have changed this header in both of these files like 6 times now. which just, every time I have to do that, it grates on me that I have to do both. 1014, symbol index. All right, symbol index. And regardless of how much time it actually takes, it just decreases my quality of life drastically. Drastically. Oh, oh no, oh no. All right. All right. All right. Maybe this will actually work. I mean, it's not, so it's not crashing the game. So now let's go back to, let's start simply. Let's get our prints back. Remember when those were crashing us? So let's just try those, right? That's simple enough. Okay, we get those. That's good. Pre-check, post-check. Good. Now, let's see what happens if we do this. Panic! Yields. All right. That's good. Okay, so now we want to do the more sophisticated version wherein we pass arguments, which is going to be slightly more interesting. What is wrong with lambdas in C++? First of all, to use them reasonably, you have to include standard : function, which means you're in template hell off the bat before you do anything, right? Then, you know, they'll randomly heap allocate if you pass a little bit too much data into them. The syntax is gross. I don't know. I mean, those are sort of the main. If it forces me to use templates, I won't use it. Like anything, you have not seen me type std : at all during any of these streams, and there's good reasons for that. Yeah. Okay. I type standard on every identifier. Okay, so we are successfully array bounds checking, except, okay, here's what I'm going to do. See, there's a forking path because we have to do, I'm going to write this down. We have to do call with arguments, so we can report the file name and line number and stuff. But B is we have to go back and make this work for signed or unsigned arguments as well, or unsigned array accesses, which should be easy, but we have to do it and test it. You can't actually write template type name F everywhere, because if you want the thing where you can pass a function pointer or a lambda, then it needs to do something special, doesn't it? Or did they fix that? Okay, let's, so we need to call, oh man, this is going to be annoying. This is gonna be annoying. This is gonna be annoying. It won't be that bad, actually. Okay. Okay. Andreas from Insomniac wrote a post about how to avoid that case. I will not read it because I am getting the hell out of C++. Yeah, dude, just all that stuff is bananas, and I will have nothing to do with it. I will have nothing to do with it. Okay. So we need to call array bounds check fail. Wait, we take a zero terminated file name? Okay. When did that happen? All right, that makes this maybe a little easier. So we need to pass 4 arguments in. Four arguments. Now, the calling convention, all right, we actually have a thing to help us with argument passing. All right, so here's what I'm going to do. Passing arguments. So we want the line number index limit of the array, the line number, and file name. And we're just going to pass 0 for all these things. First, because we're going one step at a time. We're going to 0, C, RX, pass single argument. Oh God, I need an argument state. I might have. Guess what? Guess what I get to do? Whoops, I can't put the equals null there. I have to put it in the other declaration because it's C++. God damn it. Wait, that doesn't even work, does it? It might work. I don't know if that works. I don't care. We're just going to call it. What the hell? All right. Let's see if that compiles. Cannot convert argument 4 from all this to the thing without the argument state. Did I not save the header? I don't understand why you think you need that. cannot convert argument 4 from void cdecal with the state to something with only code gen mode. Why does it think that? Because here it has the state. Here, oh, it's in the, right. It's C++. Line 1710. I put the state. I put the state. I put the state there. What is going on? 1, 2, 3, 4. It's there. It's there. Why do you think it isn't? Clean solution, build. Do I have to ban this game dev 513 guy? What's going on in chat? Can anyone tell me what emit code for procedure call? It thinks there isn't an argument there, but there is. I put it. It's the. I put it there, and it's in the header. Okay, here's where we type def. Anyway. It passed type def, blah. Code gen callback, If I can remember how to do this. It's been a while since I typed def to function pointer. Apparently didn't like something, syntax error. Oh, because I put them in the wrong order because this is C++. All these things that I'm so happy about when I'm programming in my own language that I don't have to think about it. All right. Syntax error. Argument state. Are you... God. Strut. Argument state. How stupid are you? Wasting my time. Identifier code gen callback. In x64. Oh wait, this is supposed to be capital. Declared identifier code gen callback. Line 59. This is line 41. Oh, Callback. That's a good typo. Callback. Number flags, undeclared identifier. Yeah, we don't want that. 0. Whoops. Now what? Error. Cannot convert argument 5 from argument state star in line 112. Finally. God. I mean, I just have fun with the raging at C++ now because I don't have to worry as much. Because I'm leaving it behind, I'm happier about it. So, there's a way of being mad, but having fun that you're mad, as opposed to like being mad and being locked in being mad, right? So I'm having fun that I'm being mad. That is not. Oh, because we're still calling panic. So we're just going to paste 4 things: index, limit, line number, file name, and the procedure is going to be, what's it called? Array bounds check fail. Symbol index is symbol index array bounds check fail. Now let's go make that. Where did we put it? Symbol in, oh, it's in obj. Int. Array bounds check fail equals -1, and we'll go obj. Array bounds check fail. Okay. See how you like that. Well, let's see what happens. Yes. Yes. We're now calling the procedure. So now the index should be easy. Let's start with that. Static int codegen panic, or x64 codegen panic array. Limit. Well, let's do the limit, right? So codegen panic. We're going to say codegen panic array limit equals we might not. It's in a register, it's not in a constant. Because sometimes we know how long an array is, but sometimes we don't. So this is an array bounds check for something that's in a register. Right, and it's index B. Array limit bytecode register is BC index B. Oh no, you know what? No, let's do it. Bytecode register. This is an int. The limit, we'll say assert that somebody set this. We are going to move extend into there. Although and I just call that index B. I'll put this index B. Oh God, we don't have any of this stuff. Please don't tell me that I'm going to end up making this a method callback. That would just be fully C++. And false array bounds are not signed. Although we actually make it an x64. Yeah, okay, let's are always signed. Okay, true. So we're putting into A the limits. See if that even works. Obviously it doesn't. Output. Size. Do I have a okay, let's see if that does something. This is exciting. Limit is 3. That's how long our array is. Oh, let's change the array length. Let's change the array length and see it work. Instead of 3, it'll be 333. Limit is 333. Okay. Array index. We're going to do the same thing with the index as we did with the limit. Index. Okay. Well, I gotta set that. Code gen panic array limit array index. All right. Boom. Index is 333, limit is 333. What if we go to minus 333? Whoa. Why does it say positive? That might be a parsing bug for all I know. Wait, it's not. I'm not doing it right. 444, let's keep it simple. Okay, I'm passing the same number when I should be passing a different number. Array in, so simple. Too much pasting. Too much pasting. Wouldn't be prudent. There we go, 444. Now let's try a negative 444. Negative 444. I'm going to get rid of this other console that's annoying me. Yep. Someone is saying they've heard 6 minutes of coding results in 6 hours of debugging. Oh, it's Lieutenant Hummus, or whatever the LT stands for, from the Spy Party community. who I watched play Steven's Sausage Roll. That was good times. Did you ever finish Steven's Sausage Roll, dude? Because it looked like you were playing it and then gave up. I'm going to make some tea again. Is that a you gave up? Okay, so now we'll put in the line number, because the line number is going to be easy. Well, actually, yeah, sites. Insert sites. Constant. How do I, yeah, move 64 immediate into register. Negative indices works how? It doesn't work. That's the point. It doesn't work. So we're testing it with an index that's invalid. You don't have to finish Steven's Sausage Roll if you don't want to. You'll just be missing possibly the greatest puzzle game of all time. That's all I'm saying. I mean, it's your choice, man. Okay. Whereas it may seem like it has taken us this long just to insert array bounds tracks, it's actually good because now we can call arbitrary procedures much more easily. Like most of the work that has been done here is infrastructure work. So I want to say move 64 immediate into register CRAX site line number. That's easy. Still stuck on the tower. Well, you gotta, in order to make games, you have to solve the tower. I think that's how it works. Yeah, I'm telling Maxwell Perlman he has to finish the tower. I think you got fairly far, right? You got to like the snowy world or something, didn't you? Something like that. That didn't work all of a sudden. How did I... How did that crash anything? What? Seriously? This is freaking me out. What? Why is the line number there's no way that we're inserting so many bytes that our jumps are going to be too big, is it? Well, let me see. I guess it's anything's possible. And C distance is less than 128. Well, I should run the debug compiler actually if I want those asserts to fire. All right. Debug. Assertion failed site. Oh, I didn't set the site. How did we not crash if I didn't? All right. I don't understand how we didn't crash, but whatever. Probably because it ended up with a garbage pointer with a weird number in it or something. Site is BC debug expression. Nobody in chat caught that one. All right, debug builds. Hey, look at that. It says line 266. Let's see if that's right. Yes, it is line 266. So good. All right, so now all we have to do is a file name. The problem is the file name is annoying because we have to add a string to, it's not that annoying, but we have to add a string to the string table, and we kind of have to unique it because we're going to be spitting out the same file names all the time. And I don't remember how I add a string constant. So let's figure that out. String. Oh, God. Yeah, this is going to be annoying because you have to unique the strings. You have to put them in the global string table, and you have to make sure that they get patched. Okay. So we make sure this is 8 bytes, which is a very inefficient instruction. There's probably a better way to do it, but whatever. That's an 8-byte pointer to a string. We take the position because we're going to stuff that. We're going to add a 64-bit symbol patch. So what do I do to get the yay. Let me see other calls to this. Add 64. So for this, I need to know where the string is. This is a pain in my butt. Okay, the first thing we're going to do is just get any string to work. Okay, so we have this add string to emit. So one thing I could do is if array bounds checks are enabled, I could just output a string for every file name, and then we know what they all are. Yeah, I'm liking that approach. I'm liking that approach. Yeah, self-hosting ain't going to happen for a long time. As much as I would prefer to be programming in my own language, it's just not a priority. And it'll be a good time, like once the compiler is done, and I have opinions about like how I'd like to restructure it to make it better. That's a good time to rewrite it in another language. And it would be a rewrite, I think. Like it wouldn't be. Like sometimes people do automatic source translation. I mean, maybe we would do that and then just clean it up heavily, but I don't know. There's just some stuff that I want to be able to make structurally different. Yeah. Yeah, well, I mean, the other thing about self-hosting is if your language isn't done, then now your compiler is written in a language that isn't stable, that happens to be your language. So like, it's just not the best. As grumpy as I am about C++, I feel like this is the right way to do it. Okay, so that's what I'm going to do. Is I'm going to go to directive load. So every one of these, this site here will have a load associated. It'll have a pointer to whatever file it loaded in, and this record represents the file that it loaded in. And I will add an x64 specific offset into our data segment of the file name for this file used by array bounds checker, only set if we are doing array bounds checking. S64 offset into our data segment. Auto offset equals site load offset into our data segment. Assert offset not equal -1. Okay. So now we actually have to just put these in. So So we have a thing called load directives all. All right. All right, so let's do that. String to emit. Okay. Doing our data segment, section data. Do literals, our data section offset, right. Okay. For all string literals, we do the same thing. If we are array bounds checking, put each load directives file name into this segment. All right, so compiler option, no. Compiler settings, array bounds check. If interp build options dot array bounds check not equal array bounds check off. Oh, see, this is bad. If somebody changes the value of array bounds check while compiling, all right, we'll deal with it. We will deal with it. We will deal with it. Code gen. Oh, it's an x64. What, I'm forgetting what all my things are called now. This callback is for panic. Yeah. So I just want to put a note here that cleanup, we could actually get an offset of -1 if some poser changes the value, changes whether we are array bounds checking at compile time, but after some checks have been generated. This is illegal, but we don't check for it or safeguard against it yet. 6 February 2017. Okay. So if it's not array bounds check off, we've got to get phase. Okay, I've got to get the phase mutex. How do I do this? Okay. So I lock the phase mutex of the interp. I get the phase. The phase has the list of load directives. And there's one load directive per file, so I say for phase.load directives all, do some stuff. And that stuff is auto data pointer offset equals offset, let's call it offset Oh, geez. Oh, I've got to, oh God. All right, so we pad to alignment because we're storing the length and the data pointer, and then we'll store the string data. So file name, string literal, offset into our data segment. So it's just called name. We'll call it name for now. Name. So we add the count. We get the offset to the data pointer. And the data pointer offset is, right. Oh God. Then of course we need to add a patch. How do I add a patch? Oh, this is a pain in my butt. So you can't just add the string, right? Because you have to tell the linker that there's a pointer at this position. Oh, geez. And no, you know what? We're punting right now. Temporary. These are 0 terminated C strings, which is stupid, and we want to get away from them. But that is how it is right now in runtime support.obj, and anyway, this prevents me from having to get the patching right, so stuff it. Right. So we don't do any of this stuff. We just say what was that called? If it, let's call this file name. It file name offset into our data segment equals c.length minus our database. So our database is just the start of the segment, and then we pack stuff on and whatever. And then we add that, and c.add u1v 0 to 0 terminate that string. And that string is bit arrow name, right? Something like that. It's probably not going to compile. Nope. Why not? Output undeclared identifier. In x64 converter, line 140. Right. So C file name, offset into our data segment. Pass single argument. Might work. It's possible. Site load. It's not called load. What's it called? Load info. Load info. Output. I keep having output. That's what happens when you rename your variables. Add 64-bit symbol patch not found. Because that's on x64. Cannot access protected member. Oh, that's going to bite me right now. Load directives all. Must have struct 1014. All right, that must be a pointer. All right, we kind of compiled. I don't know what's going to happen. That's the debug compiler, so we got to run the debug compiler. All right. Yes. Yes. Array bounds check failed and tells us the file name. All that stuff worked the first time, which is great because usually messing with the object file is a recipe for sadness. This was not a recipe for sadness today. I'm going to check this in. Well, let me make sure it works in release mode, actually. Because I just ran the release compiler and it crashed, but I'm pretty sure because that's the executable is very old. I didn't see any questions for a while. It probably scrolled by. I was intensely trying to make sure that this all worked. So if you re-ask a question now, I could get to it. There we go. Site is main.jai 266. Yeah, so that's all good. So we got to do that. We got to make that work for unsigned. It shouldn't be that hard. What if we pass a number that overflows, underflows? Pass that where? What number where? Does autocast just work for pointers or any type? It works for any type that you could legitimately type a cast between, right? So if you have a struct by value and another struct by value, that's not going to cast right now. Although maybe I should make them cast if they're the same size. I don't do that. Yeah, but for anything, it'll work between numbers or yeah, just anything. As the array bounds, well, it's a signed 64-bit number. So if you overflow a signed 64-bit number, you're probably doing something dumb. And That can't really happen for this kind of array anyway. It can happen for arrays where you don't know the size at runtime. Like you could just have an array struct and you could poke a random number as the length of the array, and you sort of corrupted the array if you did that. Have I implemented a compile time text replacing mechanism? No, and I want to be able to program just fine without that. You can add one if you want through the metaprogramming right now. It's very easy at compile time to just pump your files through the preprocessor of your own choice. And I'll probably make a preprocessor that you can just have in the standard library and use if you want. But I don't think I want to use one. Okay. So now we have to make this work with unsigned. Well, let me think about that. Let me go back to the let's at least print. I want to make sure it's possible to get there and that we have a test case that will get there. So, it's printf in this language, you goofball. So slow. So slow. All right. So we printf this. And we'll go to main, and we'll say I is a U32 that's equal to 12. Print was that the release? That was the release build. Unsigned array bounds check. And it did not happen only there. It happened many times throughout the program. So this is a case that we will do. And let's do it. It's similar. And actually, so we're going to do that. We're going to do this, because, we always want to check. Now the trick is we want to compare a signed number versus an unsigned number. Except if the signed number is negative. No, if the signed number is negative, then you're sad anyway. So it's fine. Because the array length should never be negative. All right, so we're going to do that. All this is in common between both cases. We will say if post branch A is not equal to -1. So we might not have a branch A. We always have a branch B, because branch B is for the upper limit of the array. We'll get rid of our int3. All this code gen, all this is the same. Now, however, our compare has to be different here. So, Instead of jump if greater than or equal, it has to be jump if above or equal. And that is 0x73. I think that's correct then. Yeah, I mean, at some point, if your array length is wacky, then you'll actually see that. So if you have a negative array length because you overflowed or you corrupted it, the array bounds check will fail because any valid index will be greater than the array length, right? The array length is negative, so when you try to index it, it'll fail, and then the error report that tells you that you screwed up will tell you that the index is massively negative. So you'll see that the array got corrupted, I think. That's my theory on what will happen. But that's not what we're doing right now. We are the champions. We are re-enabling our test case. Actually, not that one. Let's just see if it, all right. Whoa. Okay, so that didn't work. We incorrectly bounds checked something valid, right? It says index is 119, limit is 256. This might have to do with well, let me just make sure that it's this, first of all. No, it isn't. Wait, what else is different? I don't think anything else is different. Oh, dough. Wait. Okay, we load A. Compare to 0. No, that's fine. On which array is it incorrectly? It's in the trailing bytes for UTF-8 array in Unicode. Trailing bytes for UTF-8. Trailing bytes. And that's just declared, I'll show you that, it's just declared as 256, right? And we're probably indexing it signed or unsigned. So what I don't get, like, what did I possibly do that's irreversible here? I don't get it. I hope I checked in. That's all I'm saying. Really? What did I screw up? what did I screw up? Wow. This is about when I revert because I don't know what I screwed up, and if I checked in at the right time, it's just faster not to bother to figure it out. Let's just see. Well, we can also just use this to try and figure it out. That's not a very helpful diff. See you later, Maxwell Perlman. All right, so here's what I'm going to do. Copy x64. Now let's watch it fail. Nope. So I really did do something. Oh, right. What I did was I enabled code to happen if we're unsigned. So currently, okay, right. That's why I was confused. So currently, any unsigned check is not happening. Okay, so it's not that bad. This actually was progress. It's fine. I'm going to redo everything I did by hand, though, because why not? Okay, I understand. No, you know what? All right. Okay, because this way I don't have to figure out, I don't have to recopy these jump indices and stuff. All right, so here's the thing. So we're loading RAX, loading RCX, jumping if above or equal. Here, let me just zero RAX. So now it should never, unless it's a zero element array, it should never go off. Right? Do I think having a recorded video of my programming might ever come in handy for debugging or figuring out what I broke? Probably not. Because source control does a good enough job of that for the most part. What? What are you talking about? How is that above or equal? Oh, because I didn't do the compare. Duh. All right. Okay, it's still failing. That is so weird. I guess let me turn on the crash only for signed because I want to verify. Oh, wait. Nope, that's wrong. So I want to leave this. I just want to take out the part where it crashes if we're unsigned. Which is this. I just want to know if that one's signed or unsigned. Okay, it is unsigned. This is freaking me out. I guess it means that RCX is 0. Let's do this. 0 in RAX, 1 in RCX. And if that's really jump if above or equal, this should really never happen. Really should never happen. Okay, it does never happen. This is okay, so it's RCX is getting the wrong value on this register. But it's not. Oh, it's 8 bits. It thinks it's 8 bits or something. Right, because it's a 256 element array. And the size the size is wrong, probably. Right, so for most operations, like binary operations or whatever, the compiler guarantees that the two operands are of the same type. So you don't have confusion about whether one of them is a different size than the other by the time you get here. But for this you do, because array indices, I don't think are casted to any particular type. Maybe they should be, but they are currently not. So by default, size b equals 8 if we don't specify. Otherwise, we get it from the number flags. And this is size b. I bet this fixes it. I bet you 5 cents that this fixes it. All right, someone owes me 5 cents. All right. So now let's legitly recreate the problem. So, right, we're dereferencing by 12. If we make it 1200, array bounds check failed. So unsigned, well, let's recheck signed now. Okay, signed works as well. So this is a total victory. This is Someone owes me 5 cents, guys. It wasn't because the table was 8-bit. It was because the index is 8-bit. Because we're taking 8-bit Unicode sub-characters and indexing by that. So that size was a different size than the array index size. I am in Seattle, dude. I moved to Seattle months ago. I want my 5 cents. Okay. Are you asking about me? Have I ever considered finishing my degree? No. There would be no point in that. $5 DLC. One extra puzzle for 5 cents. That's about right? So 600 and something puzzles times 5 cents is like 30 something dollars. Yeah. I actually, I have a couple days of very intense work that I'm doing before I go back to San Francisco on Thursday morning. So I can't collect on anyone's 5 cents. Sadly. So do I end this night of streaming there, or do we try to do anything else? Let me cross this off victoriously. x64 array bounds check. Done. So that's 2 bugs. We fixed array bounds check, and we fixed the sign. Oh, there's the return value bug. Let's do that one. Let me take a 5-minute break, and I'll come back, and I want to do the float return value bug. That's also x64. It'll have been x64 night. Where is that one on my piece of paper? There it is. It'll be x64 night. I am living in Seattle the majority of the time, and then going back to San Francisco once in a while. All right. Going back into break time. I feel like the break is over. So my notes on this bug are read xform state calling string to float. So let's, is that in sampled animation? Read xform state string to float. And I guess string to float well, let me just try reproducing this in main. I'm going to say R is float 64, string to float 1.2345. R is, well, that worked. Well, if I can't repro this bug, then there's nothing to fix. I might have been mistaken. Oh, there we go. It only happens this is a clue. It only seems to happen with multiple return values, which is weird. Right? So there, R, OK, it's 0. R, this is 1.2345. But if it's float 32, it works. So it's only if it's float 64, and it's only if it's multiple return values. Ain't that fun? Ain't that fun? Okay, so we're doing more x64. Call procedure. We do all this. We do all this. Oh wait, code for procedure. We factored it all into here earlier today. Okay. If the return value stack offset we leave 64, we pass a pointer to the result. Yes. We basically make out parameters, except that actually none of these all right, this is complicated. This is complicated. I might have to look at assembly for this. Debugged all this other stuff without looking at assembly. Okay, so for the return values, when we get the values back, I don't seem to be I don't seem to be moving this into a floating point register at all. Let's see if that happens down here. Okay, if it's foreign, we do stuff. But we don't. Oh, right, because we expect it to just be in memory. So the problem is, I want to know if this happens in LLVM. This might not be an x64. Let's make sure I left it. No. Let's not do LLVM let yet. Let's repro it. Okay. So I might just be not inserting the cast in this case at all, in which case it's not an x64 bug. Nope, LLVM gets it right. Or the LLVM backend. Yeah. So, yeah. What do we do? What do we do? What is wrong? I guess I'm going to look at the assembly and step through. Okay, so breakpoints, new, function breakpoint, double underscore, generated, main, go. Yes, I want to view disassembly, thank you. All right. So now there's going to be a bunch of junk. This is the function preamble up to the no-op. Oh good, it took under 1 millisecond to do that no-op. Thank you. Thank you, Visual Studio Profiler, for telling me this. Apparently I can't zoom the text here. Okay, so we do a bunch of stuff down to here, and we call string to float. All right, so what's RAX? Is that a float? Yes. So that's the right answer. If it's a float, but it ain't a float. So we're like not casting at all. I don't understand why. And I don't understand why the LLVM version works. We're putting this right into memory as a float, right? If I say, what if it's a double? Well, that probably prints a 0 in our print statement. Well, I could well, let's see what happens after this. So this result is in stack pointer plus hex 108. That's going to change. We've added 32 bytes to the stack pointer. Now it's there. It's probably just a ton of crap before we get to the print. It's very inefficient output code, by the way. All these instructions to get to the print. So there's no actual floating point operations in here, and there would need to be. There would need to be, because casting from float 32 to float 64, you need to, well, that's some float operations, and there aren't any, so we didn't ever generate a cast. So I wonder if this is just a weird thing, like Josh put in a Band-Aid in the LLVM version because he thought it was a bug of his. I don't actually know. What I'm going to do is check. I'm going to break when we actually generate this code. On 268. Emit code for declaration. Conditions. Line number is equal to 268. It's probably going to catch a lot of things. I don't know. Oh no, emit code for assignment? Oh, dude, yeah. This is a complicated situation. It's a complicated situation. I got to remember how this happens, because assignment. We break this into multiple assignments that use these AST extracts. And I have a feeling that really? Okay, so we make them here when we parse a declaration that has multiple things on the left. Oh, this isn't a declaration. Okay, it's not that. There's only two things that make, what? Come on, man, there's got to be a different thing. This is what happens when it's been a really long time. It must not be handled with an extract. Okay, I gotta keep looking until I figure out how this works. Comma separated. This is all this crazy. Okay, let me look for equals. It's been a long time since I looked at this stuff. What? There's so many just instances of equals. Okay, break names from expressions. That's not for this. If we didn't get an equals, I don't remember where I parsed this stuff. Okay, here's how I'm going to debug this. This is crazy. This is literally what I'm going to do. I'm not joking. I'm going to name this one Okie Dokie. And I am going to say in parser, new make ident if strings match ident name Okie Dokie I'm going to compile that. I'm going to set a breakpoint there. And then I'll be able to tell what the hell we are doing when we parse that identifier. That's an old breakpoint. Okay, we got an okie dokie. We are in parse one statement. Okay. Let's see what happens. We make a comma separated arguments. So we are considering this declarations, right? So, yeah, that's why I was confused. This isn't actually a declaration, it's an assignment, but because I was dealing with all this comma separated stuff, yeah. So, why did we do that? Oh, that's the wrong okie dokie. Never mind, this is a declaration. We're parsing this one right now. We need the next okie dokie. Okay, we're making an ident. And it's here in comma separated arguments, which is good. So we finish parsing comma separated arguments. We've got those. We got back an operator expression. So we got an equals. Okay, good. Expert S. This is all I needed. So 12097. So now we can go to the type checking part. So much crap in these menus. No, go to definition. Not the declaration, the Just make your crap work, Microsoft, please. All right. So, I want infer types as expression, and I will break here on expression s is equal to 12097. How's things going on in chat lately? Press F12 until happy. Well, declaration and definition, is there a go to implementation? Let me see. There's go to definition and go to declaration, right? Declaration is supposed to sort of be the header and definition is supposed to be the body or whatever, right? And it just doesn't work sometimes. Just like everything else in Visual Studio, it doesn't really work. Okay. Okay, so this should be an assignment, right? It's an operator expression. Oh, except we might have, okay, yes, okay. Unpack and infer comma separated assignment. This is what we were looking for. And I bet it does the right thing, because it's hard for me to imagine how it doesn't insert a cast, but maybe it, actually I sort of can imagine. So if it's a comma separated, no, it's a procedure call. So we make an extract. This is what I was searching for when I was looking for the extract stuff. So when you have many assignments into the results of a procedure, what we do is we call the procedure, and then we make little bytecodes that say, okay, extract value 0 into this variable and extract value 1. And rather than trying to pack all that into one instruction, which would be ridiculous if there's like 1,700 return values. So the extract's inferred type, this is not right. This is not right. Well, let's see. I'm poking the type of the extract to be the type of the comma separated argument, which is not right. It should be the type of the return value of the procedure. And that's why the type check's not working. I think. Yeah, so this should be proc type lambda return declarations I inferred type. I believe that'll do something. Let's run the debug compiler, because that's what I just built. Debug. Okay, that is not good, but I don't think it's related to what we're doing. That is that we didn't reserve enough space for x64 instructions. So let's table that one. That's a new bug. Can I ignore? No, because it's going to report an error. Let's just try the release compiler, because I think we maybe fixed this, and then we can move on to that. Let's see. Compiled. Hey, look, it works. Right? So float 64 returned from 32. Look at that, man. And the whole other game works, even though we changed that thing. All right. That's good. Let's close this because it's bugging me. Let's make sure this still builds. And then we'll fix the other thing. Any questions about what happened there? Press Control-R to do reverse history. This is like Windows command shell. It sucks compared to Unix shells. How come LLVM work? I don't know what you're asking. Let's make sense. Let's make sure that the LLVM backend does work. Yep, that also works. So that's good. Now let's get this new thing that we introduced. So basically, in order to be fast, I don't check the buffering on the x64 instruction output buffer every time you add something. Like it's a growable array, and you know, every time you're going to add something, it checks to see if there's room, but there's like an unchecked call that everyone calls to be fat. Oh, that didn't do it? Let me get rid of my okie dokie. Why didn't that die? That's weird. Maybe it only happened with the bad checking for some reason. I don't know, guys. Maybe I should have debugged that while I had the chance. Doesn't seem to be happening. Oh, there we go. There we go. Dude. Don't check on the solution to the problem. Just let me debug it in a new instance of Microsoft Visual Studio. Okay, so basically, yeah, we don't have enough space left in the buffer. We're calling unchecked, which in release build this is unchecked, but in debug build, we're like, dude, you better have 8 bytes. And okay. Right, so when we code gen panic, it's no surprise. This is, yeah. We probably generate a lot of bytes there. So what I'm going to do is just at the top, I'm going to say ensure space I don't know, 100, right, and 200, 400. Now it's funny that that didn't trip always, but it sort of depends. It probably depends on who was outputting what prior to getting there. Oh, we don't have output, it's C. Anyway, little bugs like this once in a while is the price we pay for speed. So I'm going to run this 20 times, and I'll consider it fixed if it doesn't happen any of the 20 times. 7, 8, 9. It's only this slow because it's the debug compiler. 12, 13, 14, 15, 16, 17, 18, 19, 20. Well, guys, I feel like that's everything for the day. This morning I wrote this fresh to-do list, and it's got so many things crossed out now. Maybe I wrote it last night. There's still some compiler bugs that are going to have to get fixed, but this seems like enough for tonight. The ones that will have to get fixed in the future are the using variable name not working at top level. That should hopefully not be too bad. That thing where I was trying to use an enum as a default argument to a procedure, and it didn't like that. It really didn't like that. And then the weird error messages when you call an overloaded thing with no arguments. They're unhelpful error messages. So we might do those during a stream tomorrow. And apart from that, that's pretty much all the compiler bugs that I know of right now. So, you know, once all the bugs are fixed, that's when I start adding features and or working on the game again. Off-topic questions? How are things going, folks? How come the LLVM backend didn't suffer from the multi-return bug? Seems like a front-end thing. Yes, I am puzzled by that as well. I don't know why that worked. All I can think of is that maybe Josh worked around it because he saw something else. So I've actually made a note to send him an email and ask him, dude, did you ever do something like that? I was going to show how I fixed assert. Was I going to show that, or was I going to save that for a demo? I don't know if I was going to show that. Is the rest of the team switching over to the new language now? Nope, and they probably won't be for a while. Because it doesn't make sense. Yeah, we're doing unrelated QA, questions and answers, whatever you guys want to ask. What is the next C++ annoyance? I'm kind of beyond all the C++ annoyances at this point. Like, those are taken care of. It's now more about reaching way further than where C++ goes, or just having certain features live up to their potential, or have the language live up to its potential. There are some cool features that are going to get added. But the ones that are slated for coming up soon are not really like giant atom bomb features that totally change the language. They're just like, okay, this makes sense. They're littler pieces. But I think people will appreciate them anyway, because some of them do have analogs in C++, and these are way better than those. Did I have fun playing in the Seattle snow? I sort of was just in a coffee shop watching the snow out the window, but that was fun. It was a good time. I don't usually live where it snows, and I get the feeling it doesn't even snow very much here, so it was good. Do I think watching streams on Twitch is a productive use of time? Well, I mean, that obviously depends on the stream. What about watching yours? I don't know. I mean, do you get something out of it? It seems to me that these can't possibly be that educational, because I'm just staring at a problem for a long time, not doing anything. But, you know, I sort of assumed that if people watch them, they watch them on YouTube at like 2x speed or something. And skip forward a lot. I don't know. But it depends on what you get out of it. Like, I feel like, so when I went to college to learn how to program for real, or even when I was in high school and was sort of teaching myself programming, we didn't have any kind of resource like this to know like how people who make games program, for example. Like that was not a thing that I could learn. And so I think it's cool that people could just observe that now. Maybe observing a limited amount of it is enough, right, to just give context. I don't think you need to watch a stream of mine or Casey's or something like daily for years, unless you want to, unless you really enjoy it. I don't know. I mean, I'm just doing this because I'm having fun streaming. I don't know what people get out of it. How was my experience at UC Berkeley? I applied there and I'm wondering if I should get in or just stick with UW. Well, I had a depressing time there, but that's because I really have never liked being in school any time in my life, and that was no exception. So I mean, it's probably a fine school. It's the only college I ever went to, so I can't compare it either. And it's probably very different now anyway, because universities have all changed massively over the past 20 years to be much more like higher ticket items about coercing students to go there and then getting them way in debt. Like, I don't know. So tuition when I went to UC Berkeley in 1989 was $820 a semester or something like that. And you could get financial aid on that. That's not how it is anymore. I don't even know what it is, but it's way, way, way higher. Even adjusting for inflation, it's way, 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 way higher. What had been the strangest bug in the witness? I honestly don't remember. I mean, you do so much work shipping a game. There are so many bugs that you fix that none really stands out right now. There's just a lot. Maybe also I'm just too tired. Maybe if I was fresh, I'd think of something. Out of all the software and tools I use for programming, which is by far my favorite? Probably this language that I'm using now that it's far enough along to use. I really don't like any more Visual Studio. It used to be kind of okay, but they keep making it worse. I really don't like Emacs anymore. I like Dr. Memory, kind of, but I don't use that very often. That's a very couple times a year sort of a thing. I don't like, most software is just kind of crappy. Like, I don't really like it. Most application software, like there are games and stuff that aren't crappy, but yeah, I don't know, man. Have you ever tried Nixos? No, and I don't know what that is. Am I planning on DLC for The Witness? No, it is a complete game as it stands. Did I make all the puzzles by hand or generated by some code? They were made all by hand, except for puzzles that you would understand were not made by hand if you completed the game. Is it possible to write a function that returns a type and then use that type as a regular type, including type checking, etc.? You would have to run that procedure at compile time and not at runtime, right? Because this is not a dynamic language, it's a static language. So if you're going to type check something, that type has to be known at compile time, but you can run that procedure at compile time to get a type return, yes. And I'm pretty sure I've demoed that. Pretty sure. And the snow has trapped you. This is not very much snow. I mean, it doesn't seem like it to me. Like, people are freaking out, but I'm looking around and it's like, there's not even any left now. Even during the day, there was hardly any. Like, I don't understand. Like, I went to a restaurant for breakfast and they were all like, for the safety of our employees, we are closed today. I'm like, what are you talking about? Maybe it's because people are bad drivers in Seattle and they don't have to deal with snow usually, so they'll all crash. Like, I don't know. But it's not like the roads are blocked or something. There's hardly any snow on the roads at all because it all melts when it, I don't know. Do I have to remake the language runtime for each language target? Do you mean the back end, like the CPU or operating system? No. There's a small percentage of the code is the back. Well, we can look. So for example, we have an x64 backend, right? And that is 1,400 lines. And then we should probably also count the object file layer. Where is it? Well, there's another, it's like 70 for obj symbol table. Where's obj writer? There it is. 840. Oh, and then another 600. So it's about 3,000 something lines of code that are specifically for x64 backend, right? Out of 36,000, you know, so it's under 10% of the compiler by source code. Must read books for programmers? I don't know. I haven't read any good programming books in a really long time. They canceled classes at Bellevue College today and suspended all until, maybe there was weather reports that said it would be a lot worse than it actually was. I don't know. It's weird. Have I considered doing a VR version of The Witness? We've played with it a little bit, and we'll probably play with it a little more, but the game itself is not really designed for VR, which makes it weird. What's my opinion on off-the-shelf game engines? I've said that so many times, I'm not going to repeat myself. Maybe somebody can point you a clip. Is there something I learned from making The Witness that I wish I had known from the start? Design principle or running your... So The Witness was sort of the first 3D game that I did, right? Or the first 3D game in a long time. My first professional game was actually 3D, but then, you know, whatever, did Braid, and then I was like, okay, we're self-funding The Witness, and it's got to look good for the game mechanics to work. And what do you do when it's 3D and you're trying to make it really look good? You get a concept artist. And so we hired a concept artist for like a year, and he was expensive, and it was not a very productive, because we didn't really know what we wanted him to do. Like, we just thought like, oh, the concept artist will draw cool stuff, and then we'll put that in the game. But you need like more to start with than that. So instead, or later, what we did is we worked with architects to design buildings and landscapes specifically. And so they then sort of acted as the concept artists, and that's how we really got traction and decided what was in the world. So, you know, we wasted $100,000 or something. I mean, we got some use out of that concept art, and he was a good artist, right? So it was good working with him, but it was too early to do what we were trying to do. So I understand that a little bit more now. I don't know. Am I married? No, I am not. You can run code at build time right now. Did I consider doing it the other way around, writing an interpreter that comes with a built-in compiler? No, because, well, I mean, that's sort of what this is, actually, is an interpreter that comes with a compiler. It just depends on what you want to call it, right? It is sort of what you said. Your artistic style. The Witness is a good fit for VR. A beautiful world that's not visually cluttered. It would be fun just to walk around that world in VR. Yeah, maybe so. The other thing, though, is that, well, we'll see. Modern computers might be fast enough to do it in VR. It's just we made certain rendering choices that are not what you would do. Like, so the gameplay depends on reflections being accurate. That's a spoiler, but it's true. And reflections immediately make your scene take almost twice as long to draw, which is terrible if you're in VR, right? So you'd rather just, if you were designing for VR, you wouldn't have water reflections. or at least not accurate ones. You'd put like an environment map over the water or something. So there's that. Have I gotten any use of that TV? A little bit, not too much. I should watch something tomorrow night instead of streaming. Do you ever get stuck working on a problem, trying to come up with a perfect solution? Like, for example, you want to write some robust pathfinding code that can deal with arbitrary 3D geometry. Trying to figure out how you can get a numerically robust, constrained Delaunay tetrahedralization. I think you mean Delaunay. I forget how to spell that. It's not how you spelled it. Tetrahedralization uses a convex decomposition when you probably should have just used a regular grid or octree. I probably learned that lesson early in game development, and I just do the simplest damn thing now. And I say, well, if it's going to be slow, we'll find out, and then I'll rewrite it. Yeah, I don't try to do high-tech stuff unless it's necessary. Oh, you just have an extra R. It's Delaunay, or however you pronounce that, and you put a Delaunay. It's kind of funny. I could stream me watching television. No, I couldn't, or I'd get kicked off Twitch like last time that I got kicked off Twitch. Do I think I'll ever make a game that I can enjoy without already knowing the solutions myself? Yeah, I've already made such a thing. I haven't released it, but there's a game that every time I go back to it and work on it, I just play it for 8 hours because I'm having fun. What would you say to someone who wants to write robust code but isn't quite experienced enough to do so? Work harder? I mean, isn't that obvious? Like, just get more experience? I don't know. Try to write robust code and see in what ways it ends up not being robust, or see if the robustness makes it too hard to write, and just figure out what to do next, how to modify your tactics. You're welcome. Is it still possible to make interesting and engaging 2D platformers, or is a solution space? No, it's totally possible to make interesting and engaging 2D platformers. There's so many undone things. Yeah, I'm using OpenGL right now. I will probably at least try Vulkan. I don't know how I'm going to feel about it, but we'll try it. Yeah, I mean, there's a lot to be said for get good as a tactic. It's really not a bad idea to get good if you can. Using OpenGL, yeah, I already answered that. All right, guys, I'm going to go to sleep. I'll see you all in the future.